My name's Martin Lamb. I teach piano. One of the hardest things that I have to teach is the ability to play several notes at the same time, each with a different loudness. Now, why do we have to be able to do that? Why does a piano player have to be able to play several notes at once with different loudness? Well, some pieces of music are rather tricky. In particular, Bach fugues. Sometimes in a Bach fugue you have to play as many as 6 tunes at the same time, all with 10 fingers. Now, if you want to bring out one tune above the others, you have to play that tune maybe a little bit louder. Now, what does this mean? On a piano, it means that when we play a note, we have to push it down a little bit faster. Now, one of the problems with trying to learn this or to teach it is that the person who is listening to himself play sometimes hears what he wants to hear rather than what he's actually playing. In other words, I might kid myself when I'm practicing that what I'm playing is actually what I want to hear rather than what I'm actually playing. Now, let me explain that a bit more. Supposing now I'm playing something on the keyboard and I want to play one note louder than the other. Well, here they are, both the same loudness. Here we have an organ keyboard, and if you like, there's the same keyboard displayed from a front-on view, so that when I push a note down, for example, middle C, it goes down on the screen. Now, the harder I push this note down, the further it sinks on the screen. Now, if I play a triad, you can see that all those notes were the same loudness. They sank the same amount on the screen. Now I'll play it so that the top note is a little bit louder than the others. Now, let me just try that again. This time, the top note was louder, the middle note was softer, and the bottom note was about midway between the two. Now, that's quite tricky to hear when you're practicing at home. What the computer enables us to do is to see what's actually happening, and that helps our ear to hear objectively what is actually happening. Now, let me play you a few chords now, and then what we'll do is we'll see them displayed on a color screen so that we can have a look at a performance and see how we did. So here goes. All right, so now we're going to have a look at a color screen. Now, as you can see, this music is color-coded, and it's color-coded by loudness. In other words, the softest notes are displayed blue, and the loudest notes are displayed this rather strange purpley color. Now, here's a blue note there, and here's a purpley note up there. Now, looking at the music like this, it's rather hard to see which notes are softer and which notes are louder, because obviously, although that note is blue, it doesn't make sense that it's necessarily going to be softer. So the way we tell is we look underneath at this Manhattan skyline here and see that each of the notes here is displayed with its loudness indicated by a little box of the same height as the loudness. For example, that note there, that C, is extra loud, so it comes out with that height. Notice that the C is a reddy-orange color, and down there it's the same color. Similarly, if we have a look on that last chord, you can see that that blue note there is rather soft compared with the others. Now, what I'd like you to do now is to listen carefully as we play this again, and we'll play it through at a third of the original speed so that you can hear the details of the loudness as you listen. Notice how on the last chord you could hardly hear that G there. Now, something else that you might notice is that some of these flashing lines indicate a raggedness in my playing. Now, the sensitivity with which the keyboard converts the velocity to loudness that we hear and the distance that the key is depressed on the picture is displayed up here as the sensitivity. Now, if I move over to this device, which is called a slider, and stroke it, you'll see that if I come back here now, that the sensitivity has changed to 1. And now when I play, all the notes come out with the same loudness. Let me put the sensitivity back again to 4 now, and talk about this part of the picture here. Squealishness is an indication of the sensitivity of the keyboard to raggedness. Now, if I want to play one note louder than the others, a way of doing this is to cheat and to crash land with one finger further down than the others. Now, when that happens, let me increase the squealishness now so that I'll cheat. And you hear that squeak? That squeak is an indication by the computer that I've cheated and played raggedly. So, and the loudness of the squeak is dependent on the loudness of my playing. So what I can do is I can play a piece of music, I can concentrate on bringing out one of the parts louder than the others. I can hear by the sensitivity of the keyboard how well I'm doing that, and I can also hear by the squealishness whether or not I'm playing raggedly in order to achieve that rather difficult effect. Now, of course, this can be used for other teaching purposes as well. If I want to see how evenly I play a scale, then you can see that the notes were all down at different depths, which tells me that I was playing that scale rather irregularly. Something that's rather hard to do on the piano, which we all have to be able to do at some stage in our lives, is to be able to play a cross rhythm. That is, say 3 notes in one part of your tune, whereas the other part of the tune is playing 4 notes in the same time, like this. Now, of course, we have to be able to do this on other instruments as well. For example, if you're playing flute in an orchestra, you have to be able to play sometimes triplets, while another instrument in the orchestra is playing quadruplets. Now, let's see, how can the computer help us to do this? This is a fairly difficult thing to learn how to do, so let's explain how the computer can do it. Well now, first of all, what the computer does is to display the elements of the rhythm on the screen in a special visual notation. Here we're going to try and learn how to play 2 notes in one hand while playing 3 notes in the other. Notice that the beats are displayed there, 1, 2, and you can see that 1, 2, 3, that the second beat of the group of 2 comes midway between beats 2 and 3 of what's happening in the left hand. So I'll play that now. I'll play 2 notes in the right hand while I play 3 notes in the left hand. Now I'll start playing it a little irregularly. Notice the arrow. What I'd like you to watch are these little arrows here. They tell me whether I'm playing in rhythm or not. If this little arrow is to the left, it tells me that I am coming too soon. This is where I ought to be playing, and this is where I'm actually playing. Here, I'm playing dead on if the arrow is lined up, and this is the case here. So let me try that again, and you'll see whether or not I'm playing in the correct rhythm. Now, what I can do is, see the sensitivity up there is displayed as 3. That's a number between 1 and 7. If I want to increase that, I stroke the slider, and now I've got it super sensitive so that any slight fluctuation in my playing will be immediately apparent up there. Watch that. And what I can do is I can adjust my playing while I'm watching this so that it sounds right and feels right while I'm looking. Because typically when I'm trying to play this myself, when I'm practicing it at home, it's always hard for me to tell whether or not I'm doing it right. I can kid myself that what I'm hearing is what I want to play, whereas what I'm doing is actually hearing. I'm using my eyes to see what is actually happening to adjust my playing so that I can get it coming out exact. In other words, my ears aren't precise enough and I can fool myself, whereas if I use my eyes, I can see exactly that that note, the second note of the group of 3, is too late, as is the third note of the group of 3, whereas the note in the group of 2 is just right. Now, supposing now I want to be able to play 3 against 5 or 3 against 4, to do that, all I do is type in, when it asks me what would I like to do, I want to change the parameters. Let's make 3 notes in the right hand against 5 notes in the left hand. And then you'll see that we have a different set of lines here, and you can see from the display exactly where they fit in. They go 1, 2, 3, 4, plonk, 5. And I can play that then on the keyboard and see exactly where I am out of rhythm. And I can choose any rhythm here, whether I want it to up to 7 notes in one hand or 7 notes in the other, and watch the little arrows move around to tell me where I'm playing in time. And it's surprising how fast a child can learn this when he's never done it before, because the visual display of the rhythm helps him understand it, and the real-time visual display of the errors, the magnified errors according to the sensitivity, helps the child understand where he's getting it wrong. And this is something which typically takes hours of practice with a piano, whereas with the computer, it's only a matter of minutes. It really is quite remarkable.